Hello and welcome. So tonight, we are looking at structural isomers. Okay, so in fact, these are the only isomers that you sort of deal with in the 12th grade in our CAPS and NSC curriculum. So that is what we are looking at. We will be doing structural isomers. So firstly, I'm writing on the wrong pad. We need to get the bamboo pad here. And let's see, do we have the mask working? Okay, so as you can see that we say that one compound is an isomer of another compound if they have if they've got the same molecular formula, but they've got different structural formulae. The same molecular formula but different structural formulae. Same molecular formula but different structural formulae. Right? That's what we mean by an isomer. So it's very important you should know what the definition of an isomer is. Sometimes, in grade 11 questions, or even maybe first in grade 12, they may ask you what is an isomer, or give two examples of different kinds of isomers where one is an isomer of another. So I'm going to look at one example very quickly, and then we'll also talk about how we can manipulate a molecular formula to make 2 or 3 different types of isomers out of it. Okay, so I'm going to take two examples. The first example is the compound or the molecule called butane, and the next one is called 2-methyl propane. Okay, so if you haven't really done much of organic chemistry or naming, or even some work on what exactly this is, don't worry too much, because we're not very interested in that right now. Right now we just want to know, if you remember, I spoke about what a molecular formula was and what a structural formula was at the beginning. This is the one that shows you all of the bonds, shows you each atom, and this one just sums up the number of atoms of each kind. So if we look at butane, butane is an a molecule that has 4 carbons and 10 hydrogens. And this one over here has also got 4 carbons and it's also got 10 hydrogens. Now if we have to draw them out, let's draw out butane. And I think green is a good color to start working with. Very bright indeed for this hour of the night. Okay, so there we've got butane. I'm going, and it's good practice to draw out all these hydrogens. Right, and there we go. So there's butane, and we can see that butane has got 4 carbons, 1, 2, 3, 4, and it's got 4, 8, 9, 10 hydrogens. So that's exactly the molecular formula over there. Okay, and in this side we've got 2-methyl propane, and if I had to draw out that, well, 2-methyl propane, let's first get the main chain. I'm going to draw 3 carbons like so, and then on the second carbon I'm going to have a methyl side chain that looks like this. Right, like so. There we go. We're filling in our hydrogens. Okay, so let's start thinking about the number of atoms. Just my bad, that last one there. Let's start looking at the number of atoms. If we have to count the number of carbons here, 1, 2, 3, 4, there are 4 carbons. And if we start thinking of the number of hydrogens, there's 3, there's 4, there's 5, 6, 7, 8, 9, 10. So we can see that they've got the same molecular formula. Remember, this C4H10 is the molecular formula. And let's just remind ourselves of that. Let me take a thin pen and just write it there in brackets. That is the molecular formula. Right, and this here is also the molecular formula. While this thing at the bottom, that's a structural formula. Just taking you back a little bit. Structural formula. This structural formula over here is certainly different from that structural formula over there. So a few things to note, and let's make a summary of this right here at the bottom, is these are 2 compounds. We say that butane is an isomer of 2-methyl propane because they've got the same molecular formula, but they've got different structural formulae. And in this particular example, I can tell you they belong to the same homologous series. Both molecules are alkanes, but they've got different names, different structural formulae, the same molecular formula or formulae, but they've also got different characteristic reaction properties and traits. So So there we've seen a good example of an isomer, compounds with the same molecular formula but different structural formulae. Be sure to go back, rewind, replay, repause, and so forth. And yeah, make notes as you go along. Be sure to revise everything in the video and try and explain it to somebody else as well. And this will be good practice for you. Okay, so I'm going to move on and we'll talk about another structural isomer. I'm going to start looking at a molecule. I'm going to talk about a compound with a molecular formula C3H6O2. Now, let's talk about the condensed structural formulae of each of these. If I talk about CH3, CH2, and Cu, CH3, CH2, and Cu, and if I talk about CH3, COO, CH3. Right. The first one over here, this is 1, 2, 3, and I see Cu over there. This is actually an organic compound that falls into the homologous series of the acids, right? It falls into the homologous series of the acids. And if you haven't heard about acids just yet, don't worry too much. You will see it in about 2 or 3 videos time and it will be really easy. So this here falls into the homologous series of the acids, and it is called propanoic acid. That's a CID, propanoic acid. And this over here is actually methyl ethanoate. This is methyl ethanoate. Now, in each of these, if you count up the number of hydrogens, there's 3, there's 4, 5, and there's 6. There's 6 hydrogens, okay? And there are 2 oxygens, and there are 3 carbons. In this case, we've got 1, 2, 3 carbons, we've got 3 and 3 hydrogens, which makes 6 hydrogens, and we've got 2 oxygens present. So clearly, these are condensed structural formulae, right? I'm just going to write that down. Those are condensed structural formulae. But from those condensed structural formulae, we can clearly see that there's a key difference in their structures. But their molecular formula is the same. So we can say that propanoic acid is an isomer of methyl ethanoate, or it's a structural isomer of methyl ethanoate. Okay, in future we'll start talking a bit more about these isomers. We'll start talking about positional isomers. For example, a bond is on the 2nd or the 3rd carbon, that's positional isomer, as well as functional isomers where propanoic acid is different from methyl ethanoate. But for now, I think that to understand that compounds with the same molecular formula but different structural formulae are isomers of one another.